In this lesson, we are going to have a look at factorizing expressions with three terms, right? And the most important part of the lesson is we're going to deal with lots of quadratic expressions, right? So let's start with what a quadratic expression is, right? A quadratic expression or a quadratic is basically a polynomial with the variable having the highest degree of 2, right? In simple terms, right, if I consider x as my variable, the maximum power for x can be 2, right, or x squared, right, and that's what we can notice in this particular statement here. Right, and that takes us to the general form of a quadratic expression, right? It's usually given by ax squared plus bx plus c, right, where x is the variable, a is the coefficient of x squared term, b is the coefficient of the x term, and c is our constant, right? Now, obviously, the next title I've written in that page is called Monic Quadratic, right? And that's the focus of today's lesson, right? When do we consider a quadratic monic, right? It is considered monic when the coefficient of x squared, right, which in this case is a, is equal to 1, right? So when the value for a is equal to 1, we consider that quadratic expression as a monic quadratic expression. So if I were to rewrite the general form with the value for a equals 1, the equations or the expression is going to look like this: x squared plus bx plus c, right? So when the value for a is equal to 1, we call that quadratic as a monic quadratic expression. Now let's jump straight into the examples of how we're going to factorize some monic quadratic expressions. Right, now I'm going to follow a methodology which we can use for the second part of this topic, which is factorizing non-monic as well. So that way we develop one set of procedures and we can apply it to both scenarios. Right, so the first and foremost is when we get an equation or expression, in this case x squared minus 5x minus 24, and the question says factorize this. Right, the very first step is we are going to compare it with our general form of the quadratic expression. Right, if I compare it with the general form of the quadratic expression, I can clearly see that the value for a is equal to 1, right? That tells me it's monic. The value for b is equal to minus 5, and the value for c is equal to minus 24, right? That's if I compare the two scenarios. Now, the next step is obviously to multiply a by c. So we need to multiply a by c. So if I multiply a times c, I'm going to end up getting a minus 24. And the next step in factorizing a monic quadratic expression is to find a pair of factors, right, that is going to multiply to give us minus 24, but most importantly, it needs to add to give us the value for b. Right, so in other words, we need to find two numbers that's going to multiply to give us minus 24, but it needs to add to give us a minus 5, right? And the two numbers we can think of that will satisfy the situation is minus 8 and a positive 3. So if I multiply minus 8 by 3, I'm going to end up getting a negative 24. If I add the two numbers, I'm going to end up getting minus 5. So that satisfies the two settings that we need to achieve. Alright, so now that we've identified the two numbers, right, basically it factorizes into two brackets. Right, one is x minus 8, the other one as x plus 3. Right, and that completes the factorization of x squared minus 5x minus 24 into its bracket form. Right, you can always, if you're not too sure about your answer, you can always check by expanding it. Right, I'm just going to do that for this particular question. We're not going to do that for every single one, so it's always good to check if you're right or wrong. Right, so if we expand the brackets, right, that's going to end up giving me x squared plus 3x minus 8x minus 24, right, combining the like terms, so I will end up getting x squared minus 5x minus 24. Alright, right, and that can confirm that the answer that we've got is correct. Right, now moving on to the second question, right, so x squared minus x minus 42, right, so again we start with the values for a, b and c. Value for a equals 1, confirming it's a monic. The value for b is minus 1, and the value for c is minus 42. Right, so if you multiply the two numbers, a times c gives us minus 42. right? And the two numbers that's going to multiply to give us negative 42, but will add to give us a minus 1, are going to be minus 7 and a positive 6. Alright, so that means the expression x squared minus x minus 42 now factorizes as x take away 7 and x plus 6, right? The order in which you put these brackets is not important, right? So you can even rewrite the answer as x plus 6 times x minus 7. So the order is not important as long as the numbers multiply to give us negative 42 and add to give us a negative 1. We've achieved what we need to achieve in this question. Right, so here's a third example. So 3x squared plus 15x minus 18. Now, before we go ahead and factorize this expression, right, the first thing I can notice in this question is there is a common factor involved amongst the three terms in the question, right, and that common factor is 3. Now, like we did with every single example in the previous lesson when we dealt with factorizing 2 and 4 terms, right, the first step always has to be to remove the common factor, right? So if I take out the common factor 3, I am going to end up with x squared plus 5x minus 6, right? The reason I say that is if we don't remove the common factor, and let's say, for example, I proceed with a being 3, b being 15, and c being minus 18, and a times c is going to give us a minus 54, right? What happens here is we are dealing with big numbers, right? Which means minus 54 is going to have a lot of factors, and right, and then we will have to narrow down which one's equal to 15. And also, by having a as 3, this no longer becomes a monic quadratic expression. Alright, and that's the whole reason why we go ahead and remove the common factor. Right, removing the common factor makes this question a little bit more simpler to deal with. Now, if I focus on my bracket, right, my values for a is 1, b is 5, and c is minus 6. And if I multiply a by c, I'm going to end up getting a minus 6. Right, so I need to deal with two numbers that multiply to give me minus 6, but will add to give me a positive 5. Right, now obviously the two numbers are 6 and negative 1. Right, so which means the expression is going to further factorize as, now the 3 common factor which we've taken out is going to stay the way it is. Then we're going to have our two brackets, right, so x plus 6 and x minus 1. Right, and that completes the factorization of this particular question. Alright, so moving on to one last example for today's lesson. Alright, so using factorization to simplify algebraic fraction. Right, so what I can see here is I have one algebraic fraction divided by another one. Now, the first and foremost thing is when we divide one fraction by another, the best way to go about it is to convert the division into multiplication by flipping the second fraction. So that's what I'm going to do here. So I'm going to rewrite the question. So x squared plus 8x plus 15 over x squared plus 5x minus 6 times by x squared plus 7x plus 6 over x squared plus 6x plus 5. So what we've done is we've flipped the second fraction, which has now changed my division operation into multiplication operation. Now, I can see that in each of the fractions, right, both in the numerator and the denominator, we are dealing with quadratic expressions, right? So what I'm going to do here is I'm going to first go ahead and factorize each of these options where possible, right? So I'm going to start with x squared plus 8x plus 15, right? A equals 1, b equals 8, c equals 15, a times c is going to be equal to 15, right? And the two numbers are going to be 5 and 3, so it's going to factorize as x plus 5 and x plus 3. So as you can see, I've gone ahead and factorized the other three quadratic expressions in that question, right? So that's given me these four products. So x plus 5, x plus 3, then this one here, and the third one, and then the fourth one, right? So now what we're going to do is we are going to rewrite this question in its factorized form, right? So that's what we're going to do here. We're going to rewrite this question in its factorized form. And that is going to be equal to, so x plus 5 times by x plus 3 over x plus 6 times by x minus 1. So that's the factorization of the first two quadratics, multiplied by, on this side we have x plus 6 times by x plus 1, and in the denominator we're going to have x plus 5 times by x plus 1. Right, so now if I go ahead and simplify this a little bit further, what I can see here is, so x plus 1 goes into itself once, x plus 6 will go into itself once, similarly x plus 5 will go into itself once. Right, so looking at this simplifying procedure, all we can see is, all we are left with at the end of this simplifying of the algebraic fraction is going to be x plus 3 in the numerator over x minus 1. So the whole question basically simplifies into x plus 3 over x minus 1. So again, the most important factor here is, right, so obviously we had the division in between the fractions. We changed that to multiplication by flipping the second fraction. Then we went ahead and factorized each of the quadratic expressions into its bracket form. And once we did that, we rewrote the question with the factorized version of each of the quadratic expression, right? And that led us to simplifying by cancelling out things that were in common in the numerator and the denominator, right? And that left us with x plus 3 over x minus 1 as the simplified version of this algebraic fraction. Thank you for listening, guys, and have a wonderful day.